I've taken three questions based on identity, right? We have to evaluate these five parts using suitable identity. Now, there's a common mistake that have been observed that this question number one, most of you do it correctly, but you apply a wrong identity on this. Now, it says using suitable identity. So in most cases, even if your final answer is correct, you don't get the full marks for that. Now, let's start with the first one. As we can see, we have to find one square of 1005 square. Clearly, we cannot calculate it directly. We have to use identity. So in this case, we have to split them in such a way so that we get maximum zero. So needless to say, it should be 1000 plus 5 whole square. Now, when I look into this, I compare with this and I find that it is in the form of a plus b whole square. So I'll be calculating it like this. A square, which is 1000 square plus 2 times a into b, a being 1000, b being 5, plus the square of the second term, that is 5 square. Now, there are 3 zeros, so in square it will be 6 zeros. So 1 followed by 6 zeros, plus 5 into 2 is 10, 10 into 1000 is 10,000, plus 5 square is 25. So in the final answer, what we'll get, this is 25 at the end, and then 2 more zeros in between for this, and then 1 followed by 2 zeros. So this is the answer for the first part. Now, if I do the next part, where most of you do it wrong, let's see what is the mistake that you do actually. Let me do the way which is wrong. You solve it like this. You actually split this like the previous question also, like the previous question, like this. You also split this as 400 plus 5 square, and you split this as 400 minus 5 whole square. And then you apply a plus b over here, a plus b whole square and a minus b whole square. Not only the sum becomes complicated, the teacher deduct the marks for not using the suitable identity. As the question says that we have to use suitable identity. So you should look into this question and try comparing with the most suitable identity. And therefore, the most suitable identity in this case is this. That is, it is already in the form of a square minus b square, right? So if I write this as 405 whole square, considering this to be a and 395 as b, so it comes out to be a plus b into a minus b, right? By applying this identity, I should write this as a plus b. As you know, this being a and this being b. So I should write this as a, which is this, plus b, 395, that multiplied by a minus b, that is 405 minus 395. So a plus b, the sum as it is 800, right? 405 plus 395. And its difference has to be 10 because it's 405 and 395. So the final answer should be 8,000. Now, if I take the next one, this one, again, this is a bit different. This is, if I do it here, this is 47 into 53. That is the third part I'm doing. So I can write this as 50 minus 3 and this as 50 plus 3. So we actually have using the same identity, but in a reverse manner. I mean, it's the RHS of this identity. Look into this. We're talking about the RHS of this identity we have, and we have to convert it in the form of LHS, the way it is written. So this will be a plus b into a minus b is a square, that is 50 square, minus b square, that is 3 square. 50 square is 2550 minus 9. So it will be 2491. And that should be the answer for this part. That is third part. Now, if I do the other two parts, let's say, in the other two part, starting with the fourth part, we have this as 7.8 whole square minus 2.2 whole square. So considering this to be A and this to be B, do not write this as 8 minus 0.2 whole square and this as 2 plus 0.2 whole square. Look into the most suitable identity. It is already in the form of an identity. It can directly be the first one, looking into the identity I'm talking about. This one here, this part can be directly substituted as A and this as B. So it should be therefore written as A plus B, A minus B, right? So that is A first term plus second term, A plus B into A minus B. So A plus B, which is 10 in this case, and A minus B, it will come as what? 5.4, I suppose, 5.6. 8 minus 2 is 6, and 7 minus 2 is 5. So its product is 56. Coming to the last part, fifth part. This is 103 square minus 102 square. So we have this as 103 square minus 102 square. Now again, you need to consider that it's already in the form of an identity. So considering this to be A and this to be B, I should write this as A plus B into A minus B. That is A plus B, which is the sum of these two, that multiplied by A minus B. Right. So it's already in the form of A square minus B square. So I wrote A plus B into A minus B. So its sum is 205, as 100 plus 100 is 200 and 2 plus 3. And the difference is 1. So clearly it is 205. So this is the final answer for the next part. So again, you need to be careful that you do not split this as 100 plus 3, 100 plus 3 whole square, and this has 100 minus 2 whole square. Even if you get the right answer at the end as this, it's not only lead to the wastage of time, but also at times marks deducted for not applying the suitable identity.